welcome to the lecture number 9 of chapter 8. In this lecture, we are going to discuss about another type of quadrilateral which is known as rhombus. It is also a quadrilateral. Okay, so without wasting time, let's start with the figure of a rhombus. As you can see, this is a figure of a rhombus. Now from this figure, we have to conclude some properties of rhombus. Okay, so what are the different properties of rhombus? Which properties must be followed by a quadrilateral in order to be a rhombus? Let us discuss about it. As likely, the first property, it must be a quadrilateral. This is the same property for any quadrilateral. Okay, so first one is it must be a quadrilateral. It must be a quadrilateral. Second property is all the sides must be in equal length. Okay, it means all the sides have same length. Likely the square. In case of square, all the sides are of equal length. Similarly, in case of rhombus also, all the sides are of equal length. Okay, so you can write all the sides are of equal length. Okay, so it means AB is equal to BC is equal to CD is equal to DA. AB is equal to BC is equal to CD is equal to DA. Third property is the opposite sides must be parallel. It means AB is parallel to BC and AD must be parallel to BC. Clear? So the pair of opposite sides must be parallel. Must be parallel. Clear? So you can write AB parallel to DC, AB parallel to DC, and AD parallel to BC. Clear? Next, fourth property. In case of square, as you can see, each angle is 90 degrees. Yes or no? Yes. But in case of rhombus, it is not true. In case of rhombus, each angle is not 90 degrees. No. Okay. So we cannot write this property for rhombus. Each angle is not 90 degrees. Okay. Each angle or each interior angle is not equal to 90 degree. Clear? Fifth property. Fifth property based on the diagonals of rhombus. Here it has two diagonals since it is a quadrilateral. Now tell me, do you think the two diagonal AC and BD are of equal length? Do they seem to be equal? Tell me. It is of this length and BD of this length. So are they look like equal length? No. In case of rhombus, the two diagonals are not in equal length. Okay, so the two diagonals are not of equal length. Understood? It means AC is not equal to BD. But in case of square, you know, both the diagonals are of equal length, but here both the diagonals are not of equal length. Okay, now it is done. Coming to the sixth point. According to the sixth point, it tells you that both the diagonal AC and BD, okay, intersect each other at a point O, and this point is point of intersection. Now, at this point, both the diagonal bisected by each other. Likely the rectangle, likely the square. Okay, so here also the diagonal AC is bisected at the point O by BD. That's why this distance is equal to this distance. Similarly, the diagonal BD is also bisected by AC at the point O. It means this distance is equal to this distance. Okay, so you can write at the point of intersection, at the point of intersection, both the diagonals bisects each other. Okay, so both the diagonal bisect each other. But since we know AC length is not equal to BD length, so we can't write that this distance is equal to this distance is equal to this distance is equal to this distance. No, we cannot write it. In case of square and rectangle, since the two diagonals length are equal, that is why we have to write this is equal to this is equal to this is equal to this. But since here the two diagonals length are not equal, so we cannot write all the four half are equal. No, simply write this half is equal to this half and this half is equal to this. Okay, so you can write AO is equal to CO, okay, and BO is equal to DO. Clear? Next, moving to the seventh point. So let's write it. What the 7 point refers? It refers that the angle between two diagonal is 90 degree. Okay, so the angle between this two diagonal here is 90 degree. Similarly, the angle between this diagonal and this diagonal here is also 90 degree. Here is also 90 degree. Here also 90 degree. Okay, so likely the square, in case of square, similarly the two diagonals have 90 degree in between them. Here also the two diagonal have an angle 90 degree in between them. Okay, or you can say this diagonal is perpendicular to this diagonal, or you can say both the diagonal are perpendicular. Okay, so seventh point, both the diagonals are perpendiculars. Okay, but in sixth number point, what we have discussed in the point 6, we have discussed both the diagonals bisect each other. Here we discussed both the diagonals are perpendicular each other. So if you want, then you can combine property 6 and 7, and you have to write that both the diagonals are perpendicular bisector of each other. Okay, so combinedly you can write diagonals are perpendicular bisector of each other. Bisector of each other. Okay, now these are the 7th points. Last point, you have to remember this point. The last point tells you that this diagonal AC, okay, bisect this angle A. Similarly, bisect this angle C. It means this is equal to this and this is equal to this. Okay, it means you can write the diagonal is the angle bisector of the oppositely vertical angle. Similarly, the diagonal BD, here this diagonal bisect this angle B. It means this is equal to this. Similarly, that diagonal also bisect this angle. It means this diagonal is equal to, or this angle is equal to this angle. So the diagonal BD also bisect the two opposite vertical angles. So simply you can write both the diagonals bisects their, okay, or they are the angle bisector of their vertically opposite angle, right? So you can write it down. Two diagonals are the angle bisector of their oppositely vertical angle, or oppositely vertical angle. Okay, now if you want, you can write it in mathematically. For this case, simply for the property 7, you have to write but that AC diagonal is perpendicular to BD diagonal. Okay, for this figure. Similarly, for the property number 8, you have to write this angle is equal to this angle, this angle is equal to this angle, this angle is equal to this angle, this angle is equal to this angle. So the two diagonals are the perpendicular, they are the angle bisector of their oppositely vertical angles. Okay, so these are the 8 property of part of a rhombus, and a quadrilateral have to follow all these 8 property in order to be rhombus. Okay, now another question arises here. What is the question? The question is, can we say a rhombus be a square? Can we say a square be a rhombus? Can we say a rhombus be a parallelogram? So these 3 important questions arise here. So let us verify whether all the 3 questions are relevant, whether they are true or they are false. So now the 4 questions that arise here are, the first question is, can a rhombus be a square? It means, can we call a rhombus be a square? When it is possible that a rhombus can be a square, if a rhombus satisfies all the property of a square, then we can say yes, a rhombus be a square. So let us verify whether it satisfies all the property of a square or not, right? Let's say this is a square, this is the rhombus, right? Now, the first property of square is it should be a quadrilateral, and rhombus should be a quadrilateral. First property is clear. Second property, all the 4 sides are equal in case of square, but in case of rhombus also all the 4 sides are equal. Third property, here the opposite sides are parallel, right? And in case of rhombus also the opposite sides are parallel. Okay, now fourth property of square is each angle is 90 degree, right? But in case of rhombus, each angle is not equal to 90 degree. Correct? So a rhombus does not follow the 4th number property of a square. That is why we can't say that a rhombus can be a square. No, we can't say. Okay? So simply you can write no. A rhombus cannot be a square. Understood? Moving to the question number 2, the reverse question. Can a square be a rhombus? It means, can a square satisfy all the property of a rhombus? Let's verify. Right. In case of rhombus, it must be a quadrilateral, and a square is a quadrilateral. The second property of rhombus, all the sides are equal. Here also all the sides are equal. Third property, the pair of opposite sides are parallel. In case of square also the pair of opposite sides are parallel. Clear? Fourth property is, in case of rhombus, the 2 diagonals bisect each other. Here also the 2 diagonals bisect each other. Okay, fourth property is confirmed. Fifth property, the angle between 2 diagonals in case of rhombus is how much? Is 90 degree. Yes or no? Yes. Similarly, in case of square also, the angle between 2 diagonal is 90 degree. It means the 2 diagonals are perpendicular to each other. So this rule is satisfied also with square. So the 4th and 5th property is also satisfied by a square. Clear? Now next property is, in case of rhombus, each diagonal is the angle bisector of their oppositely vertical angle. It means this diagonal bisects this angle, this is equal to this, and this angle. Similarly, this diagonal bisects this opposite vertical angle and this angle. So it is equal to this, and this is equal to this. Okay, and same rule is applied for a square. In case of a square also, right? Each diagonal bisect the oppositely vertical angle. That means this half is equal to this half, and this half is equal to this half. Similarly, this diagonal also bisect this angle and this angle. Okay. So a square satisfies every property of a rhombus. Though I haven't told you this property during the teaching of square, I think I have forgotten to tell you, but you can write it down now, that in a square the two diagonal are the angle bisector of their oppositely vertical angle. Okay, so angle bisector of oppositely vertical. So finally what we found? We found that a square satisfies every property of a rhombus. That is why we can say yes, a square can always be a rhombus. Okay. Yes, a square can be a rhombus. Now the third important question is, can a rhombus be a parallelogram? Let's verify. Whether a rhombus satisfies every property of a parallelogram or not, let's verify it. Rhombus, parallelogram. Okay. First property, it is a quadrilateral, it is a quadrilateral. Second property, the opposite sides are what? Equal. Here also the opposite sides are equal. 6, 6, 6, 6. The opposite pair of sides are parallel. Here also opposite sides are parallel. Okay. Fourth property. 9. We need actually almost three compulsory properties. That is why all the three properties is satisfied by a rhombus. Okay. So we don't need to prove other properties, because these three properties are the most important compulsory properties for a parallelogram, and rhombus satisfy all the three compulsory properties. That is why we can say yes, a rhombus can be a parallelogram. Okay. So simply write yes, a rhombus can be a parallelogram. Since it is a parallelogram, that means it should satisfy every property, not only compulsory property but also optional property of the parallelogram. Okay, but we don't need to prove it, because all the three first compulsory property is the mandate, okay, for proving any parallelogram. Okay, so a rhombus can be a parallelogram. Next question, can a parallelogram be a rhombus? Can we say this as rhombus? Let's verify. For rhombus, here it is a quadrilateral, and parallelogram also quadrilateral. Second property, in case of rhombus, all the sides are equal, but in case of parallelogram, all the sides are not equal. Only pair of opposite sides are equal. Okay, all the four sides in case of parallelogram are not equal. It means a parallelogram does not satisfy the property of rhombus. So a parallelogram can never be a rhombus. Okay. So, no, a parallelogram can never be a rhombus. But its opposite statement is true. A rhombus can be a parallelogram, but a parallelogram can never be a rhombus. Okay. Similarly, a square can be a rhombus, but a rhombus can never be a square. Okay. So these are the four most important questions it may be asked. So next class we will discuss about another type of quadrilateral, which is known as trapezium.